Here is another problem which was asked again in GATE 2020 on the concept of electromagnetic fields. Now, here the data given means the question given like this. For a dielectric medium, epsilon r is given and electric field E bar is given in volt per meter. And it is asked to find just rho v. It is a very simple question, but in order to say whether it is simple or not, we need to know the Maxwell equations. So from the Maxwell's first equation in point form or in differential form, we can say that rho v can be given by divergence of d bar. So rho v is equal to del bar dot d bar. And we already know the relation between d and e as d bar is equal to epsilon e bar. Hence, I can write d bar is equal to epsilon naught into epsilon r into e bar, where epsilon naught is the permittivity of free space or air. Epsilon r is nothing but the relative permittivity. E bar is nothing but the electric field given. So epsilon naught I just copied as it is, and in place of epsilon r it is given as 2.25, hence I took 2.25, and in place of E bar I just copied the entire thing which is given in the problem. Just find D bar means as the options given in the question are in terms of epsilon naught, no need to substitute the values and do it a lengthy process. Just to take epsilon naught out from the entire expression of D bar. So D bar is equal to, see, the unit of D bar is coulomb per meter square, means flux per area. So D bar is equal to epsilon naught into, I just multiply 2.25 with each and every component, like R component, phi component, and Z component. R component is 2R, so 2.25 into 2R is 4.5R, and 2.25 into 3 by R is 6.7 by R, 75 by R. 2.25 into 6 is 13.5 into AZ bar. I just multiplied with 2.25 so that I will get this as the expression of D bar just by applying the divergence formula. See, in order to solve this problem, you need to know three different formulae. One is the Maxwell's first equation in differential form, which is rho v is equal to del bar dot D bar. And the second formula is the relation between D bar and E bar. So D bar is equal to epsilon E bar, you should know this. And the third formula is del bar dot D bar. What is the divergence of a vector field in cylindrical system? Because R, phi and Z are the cylindrical coordinates. Hence, we must know the divergence of a vector in cylindrical coordinates. So this is the divergence of a vector in cylindrical coordinates. So by just here, I just copied as it is. Epsilon naught is a constant, so I am taking it out from the differentiation. So epsilon naught 1 by r I just copied as it is. Dou by dou r I just copied as it is. R into dr. Dr is nothing but the radial component of d bar vector. D bar vector is this entire vector. So the radial component of this entire vector is 4.5 r. By multiplying r with 4.5 r, you will get 4.5 r square. And 1 by r as it is, dou by dou phi as it is. D phi is nothing but phi component of d bar vector. What is the phi component of d bar vector? 6.75 by r. And dou by dou z of z component of d bar vector. What is the z component of d bar vector? 13.5. I just copied the corresponding components by just differentiating. If you observe from this differentiation, it is the differentiation with respect to phi, but this term has no phi, hence this differentiation value is 0. And this is the differentiation with respect to z. It is a constant with respect to z, and this differentiation will also give you 0. And you left with only one. Dou by dou r of 4.5 r square. 4.5 is constant, you can take it out so that we can get 4.5. Already we have a r here, that one multiplied with epsilon. Dou by dou r of r square. It is like dou by dou x of x square. X square differentiation is 2x, hence it is 2r. So r gets cancelled, so that you will get 4.5 into 2, 9 times epsilon naught. This is the value of del bar dot D bar, and we know that del bar dot d bar is nothing but rho v value. As rho v is asked in the problem, so whatever the value which we got as del bar dot d bar, it is same as rho v, and this is the answer for this problem. Hence, this is the correct answer for the problem.